Hi, this is Tej Arora. I'm an AWS Certified Solutions Architect Associate. In the AWS Quick Learn series, I will cover AWS services and features in short videos. These videos will provide a quick 360-degree coverage of a service or feature. They are suitable for those preparing for an exam or an interview or just want to refresh their knowledge. In this video, I will cover S3, the simple storage service. In this overview of S3, I'm going to cover all these different aspects. It's among the earliest three services launched by AWS. It's been around since 2006 and has been enriched with features since then. It's foundational for a lot of other services. S3 is an object storage service with extremely high availability, durability, scalability, and security. It hosts trillions of objects and supports throughput of millions of requests per second. To contrast with object storage, other forms of storage services are file storage, block storage, and database storage. It provides 11.9's durability and provides a lot of storage classes for flexibility and to optimize cost. S3 can be used for storage of objects such as backup files, log files, photos, videos, and so on. It can be used to host static website content. It's used by a lot of big companies, Amazon.com among them, Netflix, and so on. It is a de facto standard for object storage APIs, and many competing solutions offer a S3 compatible API, for example, Apache's Cloud Stack. Also, in the AWS marketplace, there are over 250 applications that integrate with S3 for various applications for disaster recovery, archiving, etc. The key artifacts in S3 are buckets and objects. Buckets are containers for objects. They are referenced by a globally unique name, also known as a prefix. They live in a region, but the name must be globally unique. Now, which region you put your bucket in can be based on many factors: proximity to your end customers, compliance, pricing is different in different regions, or distance from your main site for disaster recovery purposes. Objects are referenced by a key, also known as the name of the object. They are replicated in a minimum of 3 availability zones, except for the one zone storage class, which has redundancy across devices within one availability zone. Up to 10 tags can be associated, and they can be edited throughout the lifetime of the object. Objects have a flat structure. There is no hierarchy. However, the console supports the concept of folders for the convenience of grouping. S3 supports the notion of a prefix, which is shared by a group of objects. So, for example, if you have 2 objects with these keys, photos is a prefix and photos/user_a is a prefix. Let's look at features of S3. It provides multiple storage classes to cater to different use cases and have different pricing and performance characteristics. Storage class is an object level property, and different storage classes have different performance aspects. Here's a quick view of different storage classes. The pricing goes down as you go from standard to Glacier Deep Archive. They're all designed for a durability of 11.9's. The availability varies. However, there's 2 kinds of availability. One is what it's designed for, and one is guaranteed in the SLA, which is lower than what it's designed for. Except for one zone IA, all other storage classes, the objects are redundantly stored in at least 3 availability zones. Now, for certain storage classes, there is a minimum capacity charge, and there is a minimum storage duration charge, and there is a retrieval fee. The latency to access the first byte of the data on retrieval is milliseconds for all storage classes except Glacier, which is minutes or hours, and Glacier Deep Archive, which is hours. The different classes include standard, intelligent tiering. It automatically switches storage class of objects between standard and standard infrequently accessed based on the access patterns. The minimum storage duration that is chargeable is 30 days. It is ideal for objects whose access pattern is kind of unknown or erratic, but the performance is same as standard. The standard infrequently accessed class has lower cost but provides the same access performance. It's ideal for less frequently accessed data that need a quick retrieval. There is a minimum size and duration charge, and there is also a retrieval fee. The one zone storage class is cheaper than standard infrequently accessed, but the same access performance. There is redundancy only within an availability zone, but not across availability zones. The AZ is picked by AWS and cannot be picked by the user. It is great for data that's recreatable if lost, such as backups or analytics outputs. There is a size and duration minimum, and there's also a retrieval fee. Glacier used to be separate from S3, but now is part of it. On old objects, old Glacier API still works, but S3 is recommended. It offers a very low storage cost, about 1/5 of standard. There are 3 retrieval speeds to choose from. Expedited gets data in 1 to 5 minutes, standard in 3 to 5 hours, and bulk in 6 to 12 hours. After the data is retrieved, a temporary copy is made in S3, which can be accessed via the GET API. Deep Archive is the lowest cost class. The cost is 1/20th that of standard. It's about $1 per terabyte per month. It is lower than tape archival costs, but provides more flexibility. And there are 2 retrieval modes to choose from. Standard takes 12 hours and bulk takes 48 hours. Let's look at the lifecycle management feature. Objects are accessed at varying frequencies, usually frequently after creation, and then less frequently or not at all later. At these inflection points, it's good to move it to cheaper storage or to delete the objects. Lifecycle management helps achieve that. Lifecycle management also provides a way to delete incomplete multi-part uploads to save on costs. So a lifecycle configuration has to be set up, and this is associated with a bucket. It's an XML file with a set of rules, and a rule consists of a selection of objects using keys and tags and actions. The actions are of 2 types: a transition action, moving objects to different storage class, or the expiration objects, where the object is expired. Versioning is a bucket level flag. By default, it's disabled. Now, every object has a version ID, and when versioning is disabled, that value of the version ID is null. With versioning, you can preserve every version of every object. When it's enabled, the existing objects in the bucket are not versioned, only future objects. When you do a put on an object, it preserves an existing version and creates a new one. A delete operation on an object places a delete marker with a new version ID. Removing the marker undoes the deletion operation. By default, when you do a get, the most recently updated version is returned. And if that happens to be a delete marker, then a 404 is returned. Older versions can also be retrieved by specifying a version number. Now, only the bucket owner can permanently delete a specific version. To provide extra precaution, you can turn on MFA delete, which is multi-factor authentication delete, and the owner must present an extra auth token to delete an object if that is set up. Now, lifecycle rules can be set up to expire old versions and or archive them to cheaper storage. And it's important to do that because if the versions are not managed, they grow to a large number, and that slows down put and delete operations. Once versioning is enabled, it can only be suspended. It cannot be disabled. And remember that every version occupies storage and it's charged. Pre-signed URLs. When your application has users who do not have AWS credentials, which is a common scenario, and you want those users to upload photos to S3, for example, that can be accomplished through pre-signed URLs. So you can create a pre-signed URL and send it to the user, using which they can upload an object. A URL can be used any number of times until it expires. It can be created programmatically. And the data needed to create a pre-signed URL is a bucket name and an object key, an HTTP method such as get or put, expiration date and time, and note that object operations must start before the expiration date and time. Multi-part upload API is a way to efficiently upload very large objects, and it can be used for objects between 5 megabytes and 5 terabytes, but for objects over 100 it is the recommended way. A large object can be split into multiple parts, and each part can be uploaded separately, in parallel, and in any order. If there is a network glitch, you can resume, and only incomplete parts need to be re-uploaded. So essentially what you end up doing is you maximize the utilization of your network bandwidth, and you're more resilient towards network failures. Each S3 object or bucket can be referenced with a URL. There are 2 kinds of URLs. The URLs that are used in REST API calls to S3 service, and a website URL. The website URL is when you host a website in a S3 bucket. So let's look at the different kinds of REST API URLs. So there's the virtual hosted style URLs. Here, the name of the bucket is part of the domain name, and therefore the bucket name must be DNS friendly. And this is what it looks like. Note that the bucket name is part of the domain. It can only be used with HTTP and not with HTTPS. Path style URLs are going to be deprecated and not supported for buckets created after this date. The name of the bucket here is not part of the domain, but it's part of the URI or the path. And this is what it looks like. If you notice, the name of the bucket is not in the domain, it's part of the path. Access point URL is actually a path to a specific bucket. It's a custom path, and the access point name is in the domain, and that implies the bucket. So the format looks like this. There's an access point name, an account ID, and a region in the URL. And to reference an object, you just append the key to this access point URL. A custom URL, you can use that to associate with a bucket a custom domain name. For a bucket in this region, you can have an alias for it that looks like this, images.mysite.com. And how does one create a custom URL? So you first create a bucket whose name, the name of the domain. So for example, the bucket name here would be images.mysite.com. Then you create a CNAME record for the custom domain that points to the bucket. Now here's the name of the bucket, images.mysite.com, and this is the URL for the bucket. And you make a CNAME record to have images.mysite.com point to this. A couple of points about legacy naming. Some older regions support S3 region format, but the dot format is recommended, which is the S3 dot region. And in a URL, if region is omitted, the implicit region is US East 1, but it's recommended to always include region in the URLs. Website URL is used when a static website is hosted on S3, and the format of the URL, it's like this. The bucket name, S3-website, and the region. It does not support SSL. Now, inventory is a feature to generate weekly or daily reports of objects and their properties. The objects can be filtered by prefixes or tags. Now, this report is useful for verifying, replication status, encryption status, etc. The report can be analyzed not only by humans, but also by tools such as Athena, Redshift, and other frameworks of your choice. S3 batch operations is a feature to run object operations on a huge number of objects, and it scales up to billions. And what the S3 batch operation does is it provides status, sends notification, provides a completion report when it's done, and also sends events. There are some operations that are built in, such as changing tags, changing access policies, copying, restoring from Glacier, etc. But you can also build custom operations. For example, run Lambda functions with custom processing. For example, if you want to transcode an image, that can be done in a Lambda function. Whenever there is a change to a bucket or an object, an event is raised. The associated objects for which events can be raised, they can be selected based on prefixes, and the notification generated can be sent to SNS, SQS, or Lambda functions. Transfer acceleration is a feature to improve uploads and downloads to and from S3 by 50 to 500%. So for global users that are uploading and downloading, this improves experience. What transfer acceleration does is it uses AWS edge locations and the backbone network between the edge and the S3 bucket. And it's faster and more reliable than regular internet routing. Amazon only charges if a specific transfer actually improved in speed. It can be enabled at a bucket level, takes around 20 minutes to take effect. There is a speed comparison tool which you can use from whatever location you are, and it gives you a sense of the improvements in speed. Now, there are certain conditions to use transfer acceleration. The bucket name must be DNS compliant and not contain a period. And the endpoint to use to get transfer acceleration is different from the normal URL. So if the normal URL looks like this, then the accelerated URL looks like this, S3-accel. Now, what is the difference between transfer acceleration versus using CloudFront with S3 as the origin server? The path between the client and the bucket is the same in both cases. However, transfer acceleration is optimized particularly for very high throughput. So for smaller objects, which are less than 1 gigabyte, CloudFront is better. Now, how do you compare transfer acceleration with the Snow family of products? Over a 1 Gbps line, transfer acceleration can transfer 75 terabytes in a week. and transfer via Snow service can take about a week. So the choice between the two really boils down to how much data is to be transferred and how much network bandwidth is available. And note that storage gateway can be used along with transfer acceleration. Replication is a feature that allows automatic, asynchronous, and secure copying of objects within a region or across regions. The replica object has all the metadata of the source object. But note that lifecycle configurations that were created in the source bucket are not replicated to the destination bucket. So how do you set up replication? You select a source bucket and you set up a replication policy. So as part of the policy, you select which objects to replicate. It can be the whole bucket or objects chosen with prefixes or tags. You select a destination bucket in the same or different region. You can optionally change the destination account or the owner, and you can optionally change the destination storage class. And you can optionally enable replication time control. And replication time control, or RTC, is backed by SLA, and it guarantees replication time limit of 15 minutes for 99.99% of objects. Now, when would you use same region replication? If you want to consolidate logs in a region and for backup mechanisms where data laws require data to be within a region and not leave it. When would you use cross-region replication? It's good for disaster recovery, for compliance requiring data to be present in a different geographical area, and to provide better latency for users in the other region. Query in place is a feature in S3. It allows analytics on S3 data at rest, instead of first copying it somewhere else into some other system and then doing analytics. S3 select is one way to do analytics at rest. You can also use Athena and Redshift Spectrum. S3 select retrieves just part of an object instead of an entire object. This improves query performance. It works on objects in multiple formats. It even works on compressed or encrypted objects. It can be used from Lambda for serverless analytics apps, and it can be used from big data frameworks such as Apache Spark. Athena helps you interactively query S3 with SQL queries with no servers to manage. And Redshift Spectrum is a feature to analyze unstructured data. It can process massive volumes of data without copying it to another system, and it can scale to thousands of instances to handle very large amounts of data. Note that S3 also has support for the BitTorrent protocol. Any public S3 object can be served via BitTorrent. To a GET request, if you add the torrent query parameter, you get the torrent file for that object. The BitTorrent clients can read the torrent file and download some parts from S3 and other parts from other BitTorrent clients. When would you use BitTorrent? If an S3 object is very popular, distributing it via BitTorrent saves costs, network transfer costs, compared to every user downloading straight from S3. There is also a feature for cross-origin resource sharing setup. Suppose you load a web page from domain A, and the JavaScript in that web page accesses static content in S3, which is in domain B. Normally, browsers do not allow this due to the same origin policy. But to allow this, you can create a coarse configuration in a bucket. And what it does, this configuration specifies origins that are allowed and HTTP methods that are allowed. Let's look at data protection features. This is especially important for S3. These are the scenarios where data protection is needed. If a device is lost, or an availability zone or a region is lost, there is built-in support for protecting the data, because data is stored in multiple AZs and or devices. If there is accidental corruption, there is some built-in protection through checksums and CRC checks on data written and retrieved. If there's an accidental deletion or overwrite, you can use the versioning feature, the replication feature, and the MFA for delete discussed earlier to protect the data. If there is a regulatory requirement for document retention, then the object lock feature can be used. For object lock to be used, versioning is a prerequisite. It is applied on a specific object version, and object locking must be enabled at the bucket level. So let's look at the different configurations for locking. So there is a retain until date, which is used in compliance mode. Essentially, the object is worm protected. It stands for write once, read many, till this particular date, and it cannot be overwritten or deleted by anyone, including the owner. The legal hold is a governance mode. There is no date associated with it, but the object is worm protected until the legal hold is removed. Note that one or both of these modes can be applied to a object version. And note that trusted advisor, it checks for buckets without versioning. The limits associated with the S3 service. The number of objects that can be created is limitless. The size of an object is limited to 5 terabytes. And if an upload is done in a single put, there is a limit of 5 gigabytes. Objects that are bigger than 5 gigabytes need to use the multipart upload API. Now let's look at security support in the S3 service. Access control. So by default, when a resource is created in S3, the access is available only to the owner. IAM policies can be used to grant IAM users fine-grained control to buckets and objects. Bucket level policies or resource-based policy can use access rules at the resource level that could use non-user attributes such as HTTP referrer, IP address, source VPC endpoints, etc. to enforce access rules. There's also bucket level or object level access control lists. These are specific permissions to specific users for specific buckets and objects. One can also use query string authentication, also known as pre-signed URLs. Now, access points is a mechanism to create a custom access policy for an application. So when a bucket policy gets really huge, access points are a good mechanism because they are easier to manage. It is like managing a monolithic policy versus having smaller policies. One can create hundreds of application-specific access points, and it is a custom path to a bucket. Now, what is an access point composed of? It has a name. It has a unique URL containing the name, which looks like this. It has access point name, account ID, and the access point keyword, and a region. And there is an access policy associated. Policy includes permissions and network origin control. One can use a VPC endpoint for S3. Using this, S3 can be accessed from a VPC without having to traverse the internet. Also remember that a console flags explicitly any publicly accessible bucket to draw attention. Encryption of data in transit. If you use HTTPS endpoints, that is automatically achieved. Encryption of data at rest. There's two modes. One is client-side encryption, where client-side encryption library is used. Keys are managed on the client, and encryption decryption is done on the client. The other mode is server-side encryption. In server-side encryption, there's three kinds of that. SSE S3, where keys are managed by S3. SSE C, where the keys are managed by the client, and SSE KMS, where the encryption keys are managed by the KMS service. But in all these three cases, encryption, decryption is done on the server. Note that S3 supports access logs for auditing purposes. The S3 Access Analyzer feature, it's an optional feature to proactively analyze ACLs and bucket policies and raise alerts when there is either public access or access from other AWS accounts. Block all public access is an ability for the user to use at a bucket or account level for existing and future buckets. And this flag overrides permission settings that allow public access. It provides a way to have centralized control to enforce uniform policy, regardless of how individual buckets and objects are created. Trusted Advisor supports security by checking for buckets that have public access. Macie also helps with security. It can scan buckets to identify and report sensitive information, such as personally identifiable information. It also identifies buckets that are unencrypted, are publicly accessible, or shared with other accounts. It generates CloudWatch events that can then be used to trigger automated actions and corrections via Lambda functions and workflows. The pricing factors for S3 are, one is the amount of storage that is used, and that includes the object data plus the metadata and measured in gigabyte months. For network data that is transferred into S3, there is no charge. For network data that is transferred out of S3, if it goes to EC2 in the same region, it's free. If it goes to CloudFront, it's free. If it goes to the internet, it's charged. If it goes to other regions, it's charged. Transfer acceleration, there's an additional cost in addition to network data transfer cost. So data coming in from the internet and going out to the internet and between regions is charged when transfer acceleration is used. The other parameter that's used for charging is the number of data requests using S3 API calls. In addition, the number of data retrieval requests for certain classes, the infrequently accessed, Glacier, and Deep Archive, is also chargeable. Now, one can purchase a provisioned capacity unit, which is $100 per month for one unit, and one unit guarantees 3 expedited retrievals in 5 minutes and 150 megabytes per second of retrieval throughput. Now, this is what the free tier offers for 12 months, 5 gigabytes per month, standard storage class, 20,000 get requests per month, and 2,000 put requests per month. And perpetually 10 GB of Glacier data retrieval per month is free. The S3 metrics include daily storage metrics. These are free, provided once a day, and basically have information about bucket sizes and number of objects in each bucket. Now, metrics on requests made to S3 over API, they can be at a 1 minute interval, and they are billed as custom CloudWatch metrics. These are basically object operation metrics, and they include the number of requests, how much data is returned, the latency of the first byte, number of failures, and so on. And then there are replication metrics. This includes the total size of the objects that are waiting for replication, the peak replication time, and so on. Now, as I mentioned earlier, a lot of services integrate with S3, and this is just a small list of those. Macy integrates by checking data in S3. Athena does in-place analytics. Redshift analyzes data in S3. The IAM Access Analyzer enables the S3 Access Analyzer. Storage Gateway, it uses S3 for cloud storage. Data Sync can transfer at scale from on-premise to S3. Transfer Family can provide FTP-based file transfers to and from S3. Snow Family enables offline data migration at scale to S3. And Trusted Advisor, it does security checks for buckets that have public access, and it has fault-tolerant checks for buckets without versioning. This completes this video. Thanks for hanging in there. Thanks for watching the video. If you found it useful, please consider clicking on the like and subscribe buttons. If you can leave a comment about what you liked and what could improve, I would really appreciate that. Thanks again.